All right, so today we are talking about section 3.2a, logarithmic function examples. Um, so this section we are introducing logs, and I'm pretty sure you guys have seen them in the past, but what a log is it is the inverse function of an exponential. So basically, if something is written in exponential or exponential form, you're going to have something raised to an exponent. Like, for example, I could say 2 to the third power equals 8. Okay, that's an exponential form. But I can write this same expression in log form. In log form, this would be log base 2, so it has this little base, and that's always the number that's being raised to the exponent. And then of this number over here, 8, equals 3. So basically what log function is saying is it's saying if I take this number 2, what exponent would I have to put on that 2 in order to get 8? So that's basically what this side of the equation is asking you. So what exponent would I have to raise 2 to in order to get 8 is what log is saying. And that is equal to 3 because 2 to the third power equals 8. So the first thing you're doing here is we're just going to be going back and forth writing this. It's given in log form. We're going to write it in exponential form. So this little number down here, that's always the number being raised to an exponent. This number over here on the other side of the equal sign is always the exponent. And then it equals that number there, okay? Because again, if I'm only looking at the left-hand side, log 264, it's saying what exponent would I have to raise 2 to in order to get 64? And that exponent is 6. So in exponential form, this is just 2 to the 6th equals 64. So on number 2, again, this little number is always the base that's being raised to an exponent. The exponent's always over here on the other side of the equal sign. And then it equals the stuff that's in here, in this case, 1 over 169. Okay, notice these things are true. 2 to the 64th power is equal to 64. 3 to the negative half. Remember that negative exponent tells me this needs to be flipped over. So it's the same as 1 over 13 squared. And since 13 squared is 169, this is equal to 1 over 169. Okay, let's move down here. So again, this is just, these are all just changing forms. So 12s to the negative second is equal to 1 over 144. Okay, again, that negative exponent flips it to 1 over 12 squared, which is 1 over 144. This one would be 64 to the 1/2 power is equal to 8. Okay, remember 1/2 power, that's the same as writing this as, you don't have to do this, you're going to write it just like this. But remember 1/2 power does mean the square root of 64. Power on high and root down below, so it's the square root of 64 to the first power. So the square root of 64 is 8, just showing you it's true, but you don't have to write that form, you're just writing this form. So this one would be 361 raised to the negative 1/2 power equals 1 over 19. This one would be 12 squared equals 144. Okay, so just change forms. Now we're going to skip ahead. We're going to rewrite them. They're given in exponential form, and we're going to write them in log form. So remember that 13, or that base that's being raised to the exponent, that's the little number, the little base number here. And then of 169, and it always equals the exponent, right? It's saying what value or what exponent would have to go on 13 in order for me to get 169. That would be 2 because 13 squared is 169. So the log of base 7 of 49 equals 2. Again, because 7 squared equals 49. So when you're doing this, the number that's being raised to the exponent is always the small number of 16, and then it always equals the exponent. Okay, so log base 2 of 1/16 equals -4. Okay, so you're just changing forms. It's just kind of getting used to which number goes where in each form. Okay, I'll do one more and then we'll go on to the next section. So log base 17 of 289 equals 2. Okay, this next section, we actually want to evaluate this. We want to do it without using our calculator. So we have log base 3 of 9. we don't know what this equals yet, but that's what we're trying to figure out. Sorry, I almost put a 0 there for some odd reason. So what we're going to do here is we're going to set these equal to x. So step 1 in this section, set equal to x. Step 2, change to exponential form. And 3, solve for x. Okay, so our first thing we do, set it equal to x. Second thing we want to do is change form. So that little base number is our base of the exponent that is going to have an exponent. It always equals the exponent, so it would be 3 to the x power equals 9. Because remember, what is this asking me? What exponent would I have to raise 3 to in order to get 9? Well, it would have to be 2, right? Because 3 squared is equal to 9. So in order to solve, we just think about what would I have to raise 3 to in order to get 9, and that would be to the second power. Okay, so number 18, set it equal to x and change forms. So 6 to the x equals 216. All right, so this one's not quite as simple to see as 3 squared equals to 9. What I'm looking for is how many times do I need to multiply x together in order to get 216. So just, you can use your calculator for this. Just go ahead and start multiplying 6 together, but pay attention to how many times you've done it. So 6 times 6 is equal to 36. And so that's 2 times. Well, if we times 36 times 6 again, 6 times 6 is 36. 6 times 3 is 18. So that's 216. So I multiplied 6 together 3 times. So x would have to equal 3. Okay, number 19. Set it equal to x, change forms. 4 to the x power equals 1 over 16. This has a 1 over, which tells me x has to be negative. 4 squared is equal to 16. So here x would have to equal negative 2, right? If I have a negative exponent, that tells me that's the same as 1 over 4 squared, which is equal to 1 over 16. Okay, number 20, set it equal to x. This one's another fraction, so again, I'm going to have a negative x. 7 squared is equal to 49, so x would have to be negative 2 because I need it to be 1 over 7 squared. That negative on the exponent tells me to flip it. Set this one equal to x. 5 to the x power equals 25. So x must be 2 because x squared is equal to 25. On this one, 7 to the x power equals 49. Nope, negative 49. All right, so I know that if x is 2, that would give me 7 squared, which is equal to positive 49, not negative 49. And I know if I changed x to a negative 2, that would just give me 1 over 49. So on this one, there's actually nothing I can raise 7 to, no exponent I can raise 7 to get a negative 49, right? It's either going to be positive 49 or it's going to be 1 over 49, but it's not going to become negative. There's no exponent I can raise this to make it negative. So this one is actually undefined. Okay. And then on this last section, you're just going to be using your calculator to approximate these. So you're going to get a decimal answer. So in your calculator, you have 2 log buttons. One is just log, and one is ln. Okay. So ln and log, these are both logs. If you don't see a little number down here, you don't see a base, then that base is 10. 10 is the standard base for a log, and so it's kind of like if you have a square root. If it's a square root, you don't see a number in that little v because a square root is the standard root, and then if you want to change that, you put some other root there. It's the same kind of thing with log. If log is the standard base of base 10, you don't see that number down here. But if it changes that base to a 5 or 3 or a negative 7, that's when you see a number down here. Your calculator actually does calculate log base 10s. So that means that not only is log 54 equivalent to log base 10 of 54, but it also means when you put log 54 in your calculator, it's calculating it with a base 10. So you can just go ahead in your calculator, hit the log key, put in the number, there might be parentheses around it, and then hit enter, and you're going to get the answer. Let me hurry and quickly calculate this with my calculator. So we have log of 54, and that is giving me 1.73. Let's see, we're nearest thousandth, that means 3 decimal places. So 1.732. Okay, so easy peasy, just stick it in your calculator. Okay, now the natural log, that is still a log, but the base here would be e. So if it says that ln instead of log, the base is a number that's called e. E is kind of a number sort of like pi. It is just a number that comes out of some math applications, and it's kind of a number you see a lot, kind of like pi is. E is approximately 2.71. You don't really have to know that. Your calculator knows. And so natural log of 18 is equivalent to ln base e of 18. I'm just telling you this just so you know what it's talking about when your calculator says either log or ln. If it says log, it's assuming that your log is a base 10. If it says ln, it's assuming your log is a base e. But all you have to do is put this in your calculator, ln 18. And let me put it in mine. That is giving me 2.890. Okay, so this part really is just getting used to finding the keys on your calculator and plugging them in, and then just double check that you get the right answer. Log 23 is 1.36, and we're rounding up to 2. And natural log 9, hit ln 9, I get 2.197. All right, guys, hopefully today's assignment is pretty quick for you. If you have any questions, please email me, and I hope you have a great day.